University research produces numerous papers about software engineering. Unfortunately, many of the problems explored by these software engineering research papers have no actual application in the real world. These papers fall into the black hole of software engineering research. Andy Ko is an associate professor at the University of Washington. When he worked as CTO of AnswerDash, he experimented with some of the software engineering research coming out of academia and industry. Today on Software Engineering Daily, we discuss Andy's results. Our conversation spans the topic of education, big companies, and startups. But first, a quick word from the sponsors that keep Software Engineering Daily alive. As a software engineer, you have tremendous leverage in the employment market. Every company needs software engineers, and these companies are all competing for you, the engineer, a scarce resource. But as an individual engineer, you don't have much insight into this incredibly opaque market. That's where Hired.com comes in. Hired.com assigns you a talent advocate who works to understand your needs and works to find you the perfect job. Go to hired.com/sedaily to try out the platform today and get a $2,000 bonus if you find a job. The companies on Hired compete for you, the engineer, and they make bids to win your talent. These are companies like Facebook and Uber, companies that we know are on the cutting edge of engineering because they've come on Software Engineering Daily to talk about their tech stack. I've used Hired personally, and I've experienced firsthand the ease of finding a well-paid, enjoyable job. This was way better than replying to LinkedIn messages from uninformed recruiters, and it was also certainly better than using a job search engine. To find a great job and support Software Engineering Daily, go to hired.com/sedaily and get a $2,000 bonus upon finding a job. Check it out. It would support the show. Now let's get on with the show. Andy Ko is an associate professor at the University of Washington. He was the CTO of AnswerDash, a company that enables online businesses to provide instant answers in their applications and e-commerce stores. Andy remains involved with AnswerDash, but has shifted his focus back to academia. Andy, welcome to Software Engineering Daily.
Yeah, thanks a lot for having me.
You wrote a piece recently called The Black Hole of Software Engineering Research. This post was motivated in part by your work as CTO of a startup, AnswerDash. Tell me about AnswerDash and what were your responsibilities as CTO there?
Yeah, sure. So AnswerDash started I think it was about 3 years ago now, and this was something that came out of research. And so this was a project that was funded by the National Science Foundation. I had a PhD student that I was co-advising with one of my colleagues, Jake Wolbrock, also here at the University of Washington. And when we decided to spin out the company, that's about the time that those roles got decided. I was really the hacker. Jake was really more of the charismatic CEO type. So we just decided to put ourselves in those buckets and go off and build out our roles. And so we spent a good solid year fundraising, selling on some betas that I'd written, and eventually closed some venture capital. So when I was the CTO, really during the formative years of the company, it meant pretty much the full range of things that have to happen in a small startup. I was not only building the 1.0 product, hiring engineers, managing the team, developing our stack, worrying about what should the company culture be like? What should the engineering culture be like? I had to be head of IT too, of course, because when you're 3 or 4 people starting a business, there's nobody else to deal with laptops and hardware and networking and Wi-Fi. So every single thing that was technical in nature was my responsibility. That was a big change for me coming from academia.
What were the biggest engineering challenges that you were encountering at AnswerDash?
Yeah, were numerous. And I've actually thought quite a bit about this. I went into the business not only deep diving in as a CTO and as sort of engineering manager and lead engineer, but also as a scientist. So I went in every single day and spent about 1,000 words worth of reflection at the end of every day, trying to think about what was hard about today. What was difficult? What were the biggest challenges? And the really surprising thing to me about all of those reflections as I've gone back and read them over the past couple of months is that very few of them were technical challenges. The vast majority of those challenges were challenges that were interpersonal in nature, or they were about coordination, or they were about decision making. So an example is when you're thinking about engineering from a product perspective, what should we build? What order should we build it in? Who are we building it for? Why are we building it? These are not things that there are certain answers to. You might have a little bit of data. You might have some insights from sales conversations. And these are the types of things that if you're dealing with a little bit of tiny data and a whole bunch of opinions and a lot of very opinionated people, how do you work through those decisions? How do you come to some conclusion about that? And that's not just a matter of actually having logic and reason to decide these things, but principles and gut instincts and hopefully some sort of hierarchy inside of your company. So when you can't come to agreement as a group, there's somebody to just make the decision, somebody to make the call and move forward. So those types of things early on in a company can be very, very challenging.
And in your work as a CTO, you tried to bring software engineering research into practice, taking some of your experience in academia into the industrial realm. What kinds of research were you trying to bring to AnswerDash?
Yeah, that's a good question. It sort of begs the question, what kinds of research exists in software engineering research? And so it's worth saying a couple of things about that. Back since the 1960s, when the National Science Foundation started funding research on software engineering, a lot of the big questions were about tools and process. How do we build the right tools and the right programming languages and the right infrastructure to make projects succeed? And as that has evolved, it's sort of come in line with some of my experiences as CTO at AnswerDash, which is it's not just about tools. It's also a lot about how you structure a team, how you structure the communication between engineers on a team, how you facilitate decision-making, all of those things. And so those are really the two categories of research that exist in academia now. It's a lot of invention for new technologies, new languages, new infrastructures and platforms for solving technical problems in software engineering, but also a lot of social science about what does it mean for a team to be productive? What kind of communication has to happen? How do you align the technical dependencies in some architecture with the communication dependencies that exist on your team? So one of the really interesting studies, for example, that directly bared upon how we structured our work at AnswerDash was a study that was done by a team at Microsoft Research over in Redmond. And they were asking the question, what is the relationship between the distance between engineers? Really sort of, are they sitting next to each other in a room all the way to, are they in completely different countries and time zones? So what is the relationship between that kind of distance and the defect density of the components that they work on? Does it matter? Should Microsoft invest a lot of money in having a bunch of buildings where people are really close to each other? Or should they just say, screw that, it doesn't matter, there's no effect on defects, and we should just distribute as broadly as we can, find out where the best engineers are, and make it work through remote communication technologies? And what they found was that in a lot of cases, distance did not affect defects. But that was because in many cases, a lot of the strategies that the engineers had used were compensating for the lack of proximity, right? So they were extra careful when they were working with people remotely because they knew they had to be. So there were really smart feedback loops that engineers had to create to do that. And so when I brought that line of work, and there are sort of dozens of studies about that question, probably hundreds by now, when I brought that into the company and we were trying to make a decision about, do we allow engineers to work from home, and how frequently and how regularly? And what are the consequences going to be to defects that we release on that? Those were the types of findings that I thought were really highly relevant to informing some of our policy and really the bugs that we were shipping.
So when you're assessing this research and you're thinking about what you want to bring into practice, what is the delta there? Like, how do you look at a paper and then figure out how to implement it? And what were the challenges of actually implementing something that you read about in a software engineering research paper?
Yeah, that's a really good question. there are many challenges in using research, even research that's really well done, really rigorous, really directly applicable to questions like this in practice. An example is when you do an experiment in research. Experiments will often be like an A/B test in industry where they'll tell you, should we go this way or that way? And the problem with a research paper that just tells you which way to go, A or B, left or right, is it doesn't really tell you why. And if you don't know why, you can't really generalize from whatever place or setting that paper was studying to your setting. So when we were taking that paper about co-location and distance and defects, it was up to my engineering team and myself and everybody in the company to really think about what makes us anything like Microsoft. Here we are, 10 employees, 5 engineers. That's nothing like 10,000 engineers across the lake spread across 120 buildings. So is there anything we can learn from that? And so the only way to really make use of any of that research is to really have theoretical explanations for why it would be that distance matters. And only then, once you have that really deep explanation of the mechanism by which distance matters, then you can start reasoning about, well, if that's the mechanism, that mechanism is going to apply at Microsoft, it's going to apply here, so we can make a prediction about what effect it would have in this small setting, even though it was explored in a larger setting. And the critique that I wrote on my blog is that a lot of researchers in software engineering, because they don't have these social science backgrounds, haven't gotten to the point yet where they really are developing these deeper theoretical explanations for the findings that they're seeing.
Okay, so this blog post, it's called The Black Hole of Software Engineering Research. What does that black hole refer to?
It's really that things can't escape. They can't escape academia. And it's examples like that. So when I brought that paper to my team, talking about distance, I was essentially taking this evidence and saying, I'm going to make a policy recommendation based on this evidence. I'm going to say that for this team, co-location matters because a lot of our engineers don't have a lot of experience working remotely with people, and they're not going to be able to develop those strategies for compensating for distance. So we should work together, get to know each other first, and as we develop some of those strategies, slowly build up some expertise on working remotely before we just flip a switch and have everybody do it all at once. That the black hole part of that was really that gap. So I got questions and pushback from everybody. Things like, doesn't that mean that we're going to lose our engineers because they'll feel like we haven't given them enough work-life flexibility? How do we really know that these findings have any impact on us, right? Microsoft is not like us. It's apples and oranges. This study is useless. There's no way for us to interpret these results for our case. And so it's that massive gap between these findings that are very much looking at particular settings and trying to generalize from them, and somebody in a company trying to figure out what relationship does that have to their work. And so that black hole is really that distance between those two things.
Okay, so I want to get into the elements of this paper or this post. You write that many of our engineering problems simply aren't the problems that software engineering researchers are investigating.
Correct.
So this makes sense to me that this would be the case in academia, and I definitely want to hear your thoughts on that. What I'm more curious about is, like when a paper comes out of somewhere like Microsoft, why is there a disparity between what Microsoft is looking at and what actual engineering problems there are? Because you would think Microsoft is an engineering organization. It's got a bevy of engineering problems to choose from, and it's got close proximity to actual people doing software engineering. So it would seem somewhat different than academic research.
Yeah, and it seems like a completely reasonable expectation that there'd be a closer alignment there. And in many ways there is. There are actually a lot of mechanisms that Microsoft Research uses to do that. I was an intern for about 3 months at Microsoft Research back when I was a graduate student. And a lot of what I did was actually just leverage the fact that I had a Microsoft badge to spend a lot of time in a lot of engineers' offices. I did a whole field study going out and doing direct observations of the work they were doing. And I could only do that because I had a badge. I couldn't do that as an academic, couldn't do that as a researcher. So there are things there at Microsoft that many of the researchers have leveraged. Other great examples are things like some of the seminal work on formal methods and applying it to device driver validity checks. So Tom Ball led a lot of this work I think more than a decade ago at Microsoft Research. And they did a bunch of really fundamental work to try to prove that drivers weren't going to crash, and found a way to apply that to, I think it was Windows 2000. And so that became part of the device driver verification process. So there, it's a lot easier for them to take some basic invention and find an application for it, because there's a massive number of engineering teams, and one of them is likely to have that problem, and they can go and find a way of spinning it out. So what their model is they'll go and take a year off from Microsoft Research and get it into product. So that does actually happen quite a bit. When I say that a lot of the problems that software engineering researchers are working on don't have as much relevance to practice, I'm really speaking more broadly about the culture of software engineering research. As a computer science research discipline, there's a certain type of research that is viewed as valuable, and most of that is invention. Create a new language, create a new tool, find a better way of detecting security vulnerabilities. These are the types of things that computer science professors are valued for, right? You invent something, and that's what gets you a research publication. That's what gets you tenure. That's what helps your students get tenured positions in academia. And in computer science, there's not as much value placed on understanding the social dynamics of work, for example. And so we don't see as much discovery on that space. And I talk in the post as well about, it's mostly a training thing too. Computer science researchers generally don't know how to answer those questions. They don't get background in how you would go investigate some of the coordination and communication challenges that happen in teams. So even if they're interested, they don't always have the skill set to apply research methods to get answers to those questions. And there's not really anybody else in academia that has those skills and is also interested in software engineering, with a few exceptions, myself included. And so there's a small set of us, maybe I would say 15, 20 researchers in the world like myself, that kind of have that intersection. And we're the ones who are going off and looking at some of those questions.
So thinking about the roots of what you see as this problem, you write that college courses don't teach many classes on software engineering. Why aren't there many classes about software engineering, and how does this lead to the types of effect or impact that you were describing in this post?
That's a great question, too. I think that computer science curricula, really across not only the United States, but across the world, is still very much in development. It's not something that there's a lot of agreement on. There are bodies like the Association for Computing Machinery, the ACM, which is the professional society for computer science, that have put together curriculum and standardized it in some sense. Most computer science departments don't necessarily follow those standards. They do exist as a sort of a target for a lot of computer science departments to reach, but it's very slow in getting there. And so things like that curriculum standard have pretty substantial portions of software engineering in there, but they really are just a small little piece. These are not programs that are designed to train engineers primarily. One of the metaphors that I'll often use when I'm talking to students about this is you have to kind of think about the difference between, let's say, physics and mechanical engineering, right? If you're a physicist, if you're an undergraduate physics major, you're primarily not going to learn how to build engines. You're not going to learn how to build machinery. You're not going to learn how to do the types of things that a mechanical engineer does. You'll learn about the fundamentals and the theories behind all of that engineering, but not how to do that engineering. Computer science hasn't had that split yet,
Well, let me interrupt you there. This is something I think about a lot. This idea of theory versus practice. And I remember first hearing about this dichotomy a lot in my computer science classes. And what I don't understand is after spending some time, in industry, after getting my degree, what it seems like to me is that in computer science is kind of this field where there's not much of a dichotomy between theory and practice, because all of the theory, the way that computer science is structured and how widely computer science principles are used, there really is very little difference between theory and practice. Stuff that is theoretically relevant instantly gets implemented into something practical. Would you say that's accurate?
That's an interesting claim. I got to think about whether or not I believe that it's actually that fast.
Well, so what are the areas of computer science that seem more explicitly theoretical, such that it would be disjoint with what is considered practice?
Well, I think that it really comes down to this gap between a fundamental discovery of an algorithm or a data structure or a way of computing something, and the packaging of that in a useful form. So let me give an example. A few years ago, I wrote a paper that was trying to look for a fundamental algorithm that allows us to take all of the verbal natural language on the web about things that people are encountering with software. So defects that they're encountering, usability problems. So think of discussion forums or tweets where people are saying, like, I just clicked this button on Firefox and it exploded, right? How do you take all of that writing out in the world and start to aggregate it so that you can get these nice data streams of every single problem people are encountering? Because in most cases, people don't report these problems as bug reports. You can't find out about them. So I had invented this algorithm for going out and taking all of that natural language and trying to synthesize it and aggregate it into these really useful data streams, right? So zoom ahead 3 years later, I'm in AnswerDash. I'm thinking about product. One of the really critical needs that we had for our analytics backend for our customers was exactly that problem. How do we take all of this knowledge that's coming in through things like their ticketing systems, anything on their social media data streams, and try to give them that same sort of understanding? So here I was in this moment as a practitioner trying to decide, can I use this research that I myself have invented? Right? I know exactly how it works. I know how to rebuild it. I know every single part of it. I don't even have to read the research paper to do it because it's all still in my head. It's fresh. And I sat down for about an hour and tried to figure out, what's this gap? What do I have to do to be able to make this work in our product? And there were so many little tiny questions, things like scalability concerns I hadn't investigated. Which NLP stack would I use to actually process all of that natural language text? Which ones actually had a robust maintained community that we're going to develop further, right? Am I going to do an open NLP thing? Am I going to do NLTK? Where is the investment being made in the community? And once I ended up with these several hundred questions that had no answers, I realized that, yeah, the basic research was really, really directly applicable in this situation, but without all of those other smaller practical details figured out and packaged up in something I could just drop into our product, I couldn't do it. I couldn't justify the risk as the product lead deciding to invest in answering all of those questions because there was too much to know.
So you mentioned the term basic research, and I hear about this a lot when it comes to biology or chemistry. I don't hear this as much about computer science. So maybe this will help us come to a more concrete conclusion of the theory versus practice. What defines basic science research in the domain of computer science?
It's a really interesting question. When I think about that, it often comes down to questions of generalizability. Much of the knowledge that we produce in practice in software companies, many of the questions that we answer, for example, how can I make this API scale for this product that I'm releasing? The answers to those questions are relevant to that moment, to that company, for that technology stack, maybe for the next year, maybe for the next year or two. And it's not that, researchers are the only ones answering questions that don't have answers. Everybody's answering questions that don't have answers. It's just a question of whether or not the answers are true and relevant for a period of time. So the way I see it usually is that practitioners are answering questions that are relevant to them in that moment for a short time horizon, 6 months, a year, maybe a couple of years, but it's going to change. The question's going to change. Academics like myself doing basic computer science research, we're trying to answer questions about computing that are going to be relevant ideally forever and that have answers that are true forever. And that necessarily means that we have to strip away all of the practical details, all of the context of today, and try to find the fundamental part of that question that really is relevant forever and the fundamental answers that are really true forever.
Do you think that's really possible? Because there's so many moving parts in computer science and software engineering. Well, I suppose certainly there are some fundamentals, but it seems so hard to pick those apart. Like, for example, I think in your post, The Black Hole of Software Engineering Research, you talked about an article about remote work, for example. And I think about remote work 3 years ago versus remote work today, it's dramatically different. Even just something like Slack completely changes the mathematics and the fundamentals. But I don't know. Maybe that's a commentary on the half-life of that specific research paper rather than the entire computer science research realm as a whole.
Yeah, it's really a question of abstraction, ironically, right? So if somebody were to go do a research study in computer science, looking at something like Slack and looking at the particular affordances and features and capabilities that something like Slack has, it wouldn't be relevant in 5 years, right? Maybe Slack goes out of business in 5 years and it's replaced by something else. What we try to do as researchers is take those questions that we might have about Slack and generalize them to a point that they aren't about Slack, but they're about something that's fundamental and more broad than just the affordances of Slack. So an example is, what is a question about Slack that is equally relevant to a question about IRC? Or other types of group chat mechanisms that have existed for decades that people have been using to support software engineering. I mean, Mozilla still uses IRC, and I don't know if Slack is slowly percolating through it, but it's really not that different. So a question might be something like, what are the mechanisms that are afforded by broadcasting to a channel as opposed to sort of having to craft a message that is directed towards a specific set of people? How does that change the dynamics of communication in a software engineering team? That's not specific to Slack. That's not specific to IRC, but it is something that's true to both of them and will be true for whatever is invented after Slack that has slightly different features.
Yeah, that's a really good approach to finding a timeless topic to approach if you're doing some sort of research. Engineers are always looking to simplify. To simplify testing and deployment, engineers turn to CodeShip. CodeShip is continuous integration and delivery as a service. With CodeShip, your tests are executed against your code automatically whenever you push to GitHub or Bitbucket. On Software Engineering Daily, we've done several shows about DevOps, and continuous deployment is key to DevOps. It's a great way to break down the wall of confusion between development and operations. Managing your own testing infrastructure is painful. That's why you want a service like CodeShip to do it for you. If you have a huge number of tests, you can use CodeShip's Parallel CI to run all your tests in parallel. CodeShip will spin up containers on their own infrastructure to run your tests in parallel. If the code passes your tests, CodeShip will deploy it automatically to your users. Companies like Product Hunt are already using CodeShip to speed up and simplify development. To sign up for free and start shipping today, go to codeship.com. Or to try out CodeShip's new Docker platform, go to codeship.com/Docker. I read this post that you wrote, and I read some of the responses. One response I read was a comment on Hacker News from somebody named Nick P. Security. And he was saying that there actually is a lot of research that is relevant. So your contention was just basically that a lot of the software engineering research in academia, and I guess otherwise, places like Microsoft Research perhaps, is not as relevant. And Nick P. Security was saying that there's actually a lot of research that is relevant, but it's behind paywalls, and it actually inhibits the information flow from percolating out. What do you think of this hypothesis?
Yeah, no, I think that there are even papers in software engineering research that have shown that software engineering research is relevant. There was a great one that went around and actually surveyed a bunch of engineers and taught them the results and discoveries of papers and kind of assessed how relevant those discoveries were. And they actually found that there was this broad set of things that were directly relevant to their work in direct ways and in sometimes abstract ways, but always useful. So it's not the case that I think there's nothing out there. There's plenty of work that's greatly applicable, just not always accessible, like Nick was pointing out with the paywall issue. And it's a big debate in academia now, not just in computer science research, but much more broadly, about how do we resource and fund sort of the economic structure of making this material available. It is not free to put something on the internet. It costs money. There's bandwidth issues, there's editorial issues, there's all of the volunteer time that we give as academics in order to edit and organize and collate all of this material and put it out online to make it accessible. I mentioned ACM before, our professional society. They have a massive staff of people maintaining the digital library for ACM. Who pays for all of those staff to make the hundreds of thousands of research papers accessible? So paywalls may be a terrible idea for how to pay for that, but there has to be some alternative to resource it. Is it a tax that we put on the public so that they're paying for it? Do we increase the budget of the National Science Foundation and the National Institute for Health so that they can pay for it? And they're giving a grant every year to all of these journals and digital libraries to pay for that staff. It is not a free thing, so it has to come from somewhere. That's really my view on it.
Well, so let me ask you a kind of a tangential question. So, I feel like I've gotten the value that I've gotten from academic research papers tends to be on the side of like very, very concrete technical stuff like cap theorem, Paxos, I don't know, some like big table. That's obviously a Google paper, but very academic like. But the stuff like that's like rooted in cultural or practical stuff, like here's some work we did on working remotely. I think that the valuable information that I've gotten has been more out of like blog posts and Medium posts and comments on and discussions online. Is it possible that type of material is more relevant for people to read rather than these very dry white papers?
Yeah, I think there's a really open debate now happening about what the right form for disseminating some of this stuff is, because we don't, as researchers, I don't write papers as something intended for the broad public to read. I write them to my peers to develop and build knowledge. And when I write to the public and I try to write and disseminate some of that knowledge, it is in the form of blog posts. It is in the form of tweets. It's something that I put, maybe in a video on YouTube somewhere. And it's that type of material that I think really distills and summarizes and synthesizes these things into really consumable pieces of knowledge that really summarize everything that we've known for the past 15 years of efforts that we've done in our PDFs and our white papers and other things that we've written to ourselves. I do think that's the right channel for disseminating it. There are other structural issues with the fact that my job as a tenured professor is research, teaching, and service, but it's not dissemination. I don't get paid to disseminate. I do that voluntarily. I do that, on top of all of my other duties. And so when I go off, and when I'm talking to you right now, this is not something I'm being paid to do. This is something I do on top of all of my other job responsibilities. And until academia really decides to incentivize that fourth activity of really taking the work that we've done and finding a way of disseminating it to the world, I don't think we're going to make a lot of progress on this, because it's going to take a lot of really intrinsic volunteer work for us to do that.
So tell me more about the kinds of responses that you got from the community after writing this post.
Yeah, I got many more responses, in person and also back-channeled on Facebook than I did published in public on the blog. And that's largely because people they don't always feel safe talking about some of these things, because I was very critical and self-critical of the field of work that I work in. So some people took it personally, right? Some people thought that I didn't fairly treat the efforts and intents of a lot of the work that's happening in the field. Other people took it very constructively and thought about what can we do to actually improve some of these things. And so there are really concrete things that have come out of it. Things like, how do I change my software engineering class to be more relevant and draw upon this work in more ways? An example is a lot of the classes that academics teach in software engineering really are surveys of research tools and inventions that have been created. How can we broaden those classes to cover the broader set of knowledge that we have so that students who are taking those classes learn about everything that we know as opposed to just one tiny sliver of what we know in those classes. So, part of it is just going through these traditional channels. How do we get this into courses? A lot more of us now are teaching massively open online courses, MOOCs on things like Coursera and Udacity. So getting that same material into those large-scale courses probably broadens the reach of it quite a bit. So I think that's where a lot of the impact is going to go, is finding these channels through academia that maybe are maturing and developing in new and interesting ways and trying to get the knowledge that we already have out through those channels.
I'd love to talk a bit more about AnswerDash and some of the lessons that you've discussed from the post that you wrote. Put it in more direct context. So talk in more detail about what AnswerDash is. Yeah,
happy to. So AnswerDash started with this fundamental observation that when people are browsing around on the web, and let's say they're using a web application or they're on an e-commerce store, there are this vast number of questions that people have about their experience, just how to use a UI of an application or how to answer some question about a product that they might want to buy. And there's not an easy way for them to get those answers. It really boils down to maybe you go post a question in some technical support forum. Maybe you go browse through 10,000 knowledge-based articles on the Google Help Center. What happens in most cases is that tech-savvy users will go and Google for an answer, and if you go Google for an answer, you'll usually find the answer in the 7th search result in the 72nd post. Everybody's had this experience of finding out that, after 35 minutes, that was the right answer to my question. I'm set now. The vast majority of users would never go to that extent to find that answer. So we were trying to solve this problem of getting people answers in context right when they had them with as little effort as possible. So the research started off with trying to answer this basic question of how do we get people to express the need that they have without having to actually verbalize the need they have? Because the fundamental problem with verbalizing the problem that you have is that it's what's called the vocabulary problem. It was discovered back in the 80s in a field that I'm part of called human-computer interaction. And that is that for any particular thing in a user interface or any particular part of content that somebody tries to describe, there are so many different words and synonyms and phrases and descriptions that people will use that the chances that the one they chose happen to be the same one that's indexed for a set of documents are extremely small. Even if you choose the best one, the best you can do is something like 10% of people are actually going to find that content. So what we were looking for was a way of doing that without having to have people express their need with words and instead express it some other way. So the idea we came up with was instead of having people type a query to search a collection of help articles, we would just have people point to something in the interface and use the interface itself as a form of controlled vocabulary. And what we found is that for any given problem that somebody had, there was usually one or two things on the screen that they would choose to represent that need. And that they wouldn't choose for other needs. And so it was a way of kind of segregating all of the content across the UI of a screen. And it turned out to work really well. We launched this on a bunch of internal websites at the University of Washington. We got some great results. The end users loved it. Companies loved it because their support tickets went down. And when we started telling this story to a lot of serial entrepreneurs around the city, they're like, why isn't this a business? I would pay for this. You can cut my support tickets in half. That sounds great. So that was the pitch that we made to a lot of the local venture capitalists. And we started building the business out of that. So now the product is at a point now where it's not even just that sort of point to get help feature, but we do dynamic popular questions on a page level. So anywhere you are on a site, we can tell you exactly which questions you are likely to need answers to without ever having to express a need. You just click on our tab and see all of that content. We do obviously traditional text search. Most people don't use it and it doesn't work very well, as we knew going into the company, because it's not likely that people choose the right words. And a variety of other kinds of search technologies that we have now too. So we've launched on all kinds of businesses, big and small. We see all kinds of wonderful effects like cutting support tickets by large percentages, even increasing conversion rates on things like e-commerce stores where the barrier to somebody making a purchase was some knowledge they didn't have about a product or some anxiety they had about a return policy. And by exposing those answers in context without having to have them navigate somewhere else to get the answer, they're much more likely to buy. So that's where the business is.
The product that you developed was based on research that you did in the university. So put that in some context of the rest of the conversation that we've had. We've talked about the elements that make research timeless enough to have an impact beyond the immediate temporal scope of when it was written. When you were doing the research within UW that led to the productization of AnswerDash, what were you thinking about that research that was timeless, that allowed it to escape the black hole of software engineering research?
Yeah. So early on, when we first started, we were strictly interested in that information retrieval question. So how do we take something somebody has pointed to in a user interface and retrieve relevant content? And that's really something that should be a fundamentally useful answer, whether it's a web stack, whether it's
right. User interfaces are not going anywhere.
They're not going anywhere. There's always going to be something that somebody's looking at, even if it's VR, even if it's a three-dimensional spherical UI. There's still going to be something people can point to. And the question is, what kind of context can we grab from that to facilitate a relevant retrieval of documents, right? So that was the basic research question. When it came down to turning that into a business and a product, obviously there were a vast number of questions that we still had to answer. Not the least of which was, aside from this being useful for end users, is this something that software teams and product teams would actually adopt? What would be the barriers to adoption? How much do they have to change about their user interface implementation to adopt it? It turned out that the way that we built it, just almost by chance, was that they don't have to change anything. It's just a third-party JavaScript snippet, right? And we do all of the work to figure out what's on the screen and allow people to point to stuff. They don't have to change anything. So that was a hugely beneficial property of that. But there were all kinds of other challenges in trying to build a business around this. Who would pay? Who has a severe enough support ticket volume and scaling problem that they would actually feel enough pain to give us a bunch of money to reduce that support ticket volume? Who believes in the idea that giving answers to people where they have the question would actually increase conversion rates on an e-commerce site? It turns out that a lot of e-commerce digital marketers don't believe that hypothesis. They believe that the best way to get people to buy something is to have a beautiful product page, to have all of the information on the page itself rather than in some widget that exposes additional information. And so, building a business is really about trying to answer all of these questions that are very much about the market, the beliefs that potential customers in that market have, the barriers that there are to getting somebody to adopt something. It turns out that the product as it is right now, as we envisioned it way back when we started the research, actually isn't that different from the inventions and the prototypes that we made in the research project. The only difference is that we have all of this knowledge now of what's the state of the market right now. How do people think about support? How do they think about conversion rates? What beliefs do they have about what causes people to buy or not buy? And do we have marketing messaging that convinces them that our new technology is a better way of solving that problem than some of the traditional tools in their toolbox?
Why did you transition out of your role as CTO at AnswerDash back to academia full-time?
Yeah, that's a good question, too. It was actually very much a planned transition. So when Jake and we were both the faculty that transitioned out of academia to do it. When we first founded the company, we had a lot of conversations with our dean at the information school and our colleagues in the information school as well, and tried to talk to them about what should this look like. We actually don't want to disappear forever. We didn't want to give up tenure to do this. We eventually wanted to come back to our academic jobs. And then when we started talking to venture capitalists, we had to have those same difficult conversations, but in a much more consequential way, right? It meant talking to the VCs and saying, there's a timeline. We're going to be here for a fixed amount of time and do our best to make this work. And so we had to find VCs that were comfortable with the idea of the two of us really being the ones that nailed product customer fit and then handed it over to more seasoned executives to scale up the business. And so really the way that we framed that whole first round of investment was, we're going to go off, figure out what the product needs to be, figure out who the customers are, figure out how to sell that to them. And once we've done that, we're going to go and find people who know how to take this from a 15-person business to a 50-person business, from a 15 customer business to a 150 customer business, and so on, and just keep on ratcheting up those orders of magnitude. I think that thinking back, just having transitioned out a few months ago, that we hit that timeline pretty closely. We were out for 3 years. That's about how long it took for us to figure all of those things out and get a product that we could sell to customers successfully and at scale.
And as you were sampling the world outside of academia, the industry world, and building a business, was there ever a time where you were like, oh, this is just better than academia, I'm just going to stay here for the rest of my life?
In small ways. And I don't think that that's an answer that can apply universally to everybody. And it's a really very personal thing. What you enjoy as a person, what kind of work environment you enjoy, what kind of problems you like to solve as an individual human being. And I think that going in, I personally had a pretty strong sense that I would enjoy it a little bit less than academia. And I was surprised to find some things that I did like about it. I loved having a team. I loved having everybody focused on the same trajectory. In academia, all of us are moving in different directions, and so it doesn't feel like much of a team, right? We're not working together on the same things in all cases. So I loved the team part of it. I loved engaging with customers and really learning about what their problems were and how we could help solve them. I think it's just really interesting for me to see all of these dynamics of just how variable customer needs are and how difficult it is to find some common pattern in them. But when it came down to it for me personally, I mentioned this difference before between questions and answers that have short half-lives versus long ones. I'm just a lot more engaged and curious about the questions that matter forever and the answers that matter forever than I am about the ones that matter in the short term.
So what about the research at companies like Google and Facebook and Microsoft? It seems like they're increasingly, or just have always done this type of research that is increasingly long-term focused, and it looks something like basic science. Why would you choose to go back to university academia rather than like Google research or something?
Yeah, I think that's a great question too. It's really almost a third type of research that's starting to emerge. A lot of this started with the recent DARPA director, the Department of Defense research agency. She had this vision for how to structure research in much more of an applied way. So what you would do is you'd have these big grand challenges with very specific problems that had so many unanswered questions that research would be an inevitable byproduct of trying to answer them. So classic example is a lot of the driverless car stuff that was happening back in the late 90s and early 2000s that eventually led to people like Sebastian Thrun leaving Stanford and joining Google and starting driverless car projects. That was her vision. And so when she left DARPA and joined Google and started Google X, that's the one of the forms of research labs that they have now under Alphabet. That was the vision, right? Let's take some really gnarly, big, complex problems, bring a bunch of smart people together and have them try to answer them over a couple of years and see if products come out of them. That's a very different kind of work than academia and Microsoft research and places like IBM research do. It's much less publication focused. It's much more problem oriented. And it has, because of that, different features. So one of the features is that it does much more productively lead to product because it's aimed towards a particular application. What it doesn't do is lead to knowledge. So I have a friend, Johnny Lee, who's been at Google for several years now. He was at Microsoft before working on Connect. We went to grad school together, and he was much more excited about the idea of working on specific problems in an R&D sense, though. So he's really just loved being at places like Google where he can tackle a big specific problem, have a team that's driving towards solving it, and not have to spend the time to write about what they've discovered in the process. Now,
Interesting.
That's good for society in the sense that maybe it leads to transformational change in certain industries, new products that we get to use, all of those things. I never get to read what they discovered. You don't get to read what they discovered. We never get to learn about what they know now. That knowledge is going to be embedded in those people and in those products and in those teams, and possibly never be disseminated outside of that company, and never be taught by anybody else. In fact, if those people lose that knowledge and that product doesn't work, somebody's probably going to have to tackle those questions all over again, which to me isn't a very efficient use of that scarce intellectual capital that we have in humanity. So it really is a huge sort of trade-off in how you structure that knowledge production, right? Do you aim it towards product and then hope that that product survives and thrives in the world and that knowledge somehow leaks out from it? Do you structure things in a way that leads to the explicit sharing of knowledge at the sacrifice of product and impact? Two very, very different visions.
Okay, so I want to start pulling to the close of this conversation. I want to talk about some computer science education concepts because you're somebody who has had a toe in the water of academia, also in industry, and it seems like you have a fairly measured approach about this stuff. One of the ongoing themes we've talked about on Software Engineering Daily is the coding bootcamps and the idea of what is the value of a computer science degree from a university? What is the value of spending 4 years in an academic institution versus spending 6 to 12 months doing high-intensity bootcamp-style education? So is the high cost of a computer science degree from a college still worth it?
Yeah, it's a very relevant question now. I know for hundreds of thousands of people, probably millions, who are really entertaining some of these career pivots. We just had Daphne Kohler, president of Coursera, here speaking on campus yesterday in the computer science department. And a lot of their revenue and a lot of their students coming in, they are taking those courses in the same way that people are taking boot camps to skill up, pivot, start a new career, and find a job as a data scientist, as a developer, whatever it is that those skills will help them achieve. So it's definitely a highly pertinent thing that's happening in the world today. Whether or not a computer science degree is worth it, I think actually, in my experience, on both ends of practice and teaching, is actually a question about who should do the training. Because I'll give a story to sort of explain this. When I was hiring engineers at AnswerDash, I had a choice between those two types of candidates. One that had a classic computer science training, one that had done a boot camp for 6 months and maybe an internship. And while both of them could code and both of them could produce software efficiently and effectively, I spent a substantial amount of my time, and so did my other engineers with computer science backgrounds, training those bootcamp trained engineers on the things that the bootcamps didn't teach them. I spent a lot of time teaching fundamentals about scalability and complexity. I spent a lot of time teaching basic concepts in software engineering and architecture, like components and encapsulation and type theory. I had to teach them about things like preconditions and postconditions on functions and why you would want to write those, and hopefully have some tool to verify them for you in your source code, what the advantages of static types are and static type checking systems are. And a lot of those things that you would only ever really get in a longer exposure to those fundamentals in computer science, they really are fundamentally useful things in practice. Boot camps don't teach them. And yes, they are going to learn them on the job, but it's essentially saying we're going to shift all of that training to industry instead of education. Is industry good at teaching people? It's not really the core expertise. I mean, as a teacher, I enjoyed teaching my engineers, and I spent a lot of time teaching them, and so did my other engineers. But finding engineers that could actually teach other engineers well is really hard and very rare.
So, I definitely appreciate that response. That's one of the more fascinating responses I've heard to that question. I think it's really, really well measured. But the thing that I really like about the boot camps is that you see such a density of information conveyance between the teachers and the students, and these teachers aren't particularly credentialed, other than that they've done a lot of hacking, they've done a lot of work, and they seem to understand this stuff really well. And the college, I feel, rests on this presumption that credentials mean something. And so, I don't know, the whole situation seems still very fraught to me. Like, I can appreciate that there are elements of boot camps that there are elements of university computer science that are not taught by boot camps. I totally get that. But I see this like huge gradient between academic computer science and the boot camp world, and it's like an unexplored gradient of different types of coursework and stuff we could do, and I think it's getting explored. But I guess I'll close with this question, which is, what do you wish that you could change about the university education system?
Yeah, I have a lot of thoughts on that. And actually, I very much am grateful for the existence of boot camps and the wide proliferation of other ways that people can learn about computing, including things like Coursera and Udacity and other online courses, and even some of the things that researchers have created, like one of my friends at University of Rochester, the online Python tutor, some of the work that we've done for teaching computing online through programming games. This massive diversity of alternatives to university education, what it's doing is it's incentivizing me, to actually do better at teaching, and teach not only things that are more relevant and more directly applicable, but actually teach in a way that's more effective than all of those other forms can, right? Think about what are the privileged things that we have at a university that we can do that those other places can't do, right? We have the captive attention of a cohort of people who are all eagerly engaged in trying to understand the fundamentals of computing. That's not a context that happens in a lot of other places. It doesn't happen online as easily. It doesn't happen in a boot camp as easily, which is a very targeted kind of training. What are the types of things we can do with our space and our expertise that we just haven't leveraged in our teaching yet because we haven't had any market competition to do that? So I think this is going to be one of those sort of raises all boats types of situations, right?
Sure.
When boot camps nail their instruction and they are incredibly valuable and useful and sort of they're operating at peak efficiency, that's going to bring up university education. And those different types of knowledge that students get in those two different settings are still going to be different, but I think that it's going to raise the quality of what we do in academia in the same way that Coursera has done a lot of that as well. So having a university instructor go and teach a course on Coursera breaks a lot of the assumptions about what has to happen in a college classroom. And a lot of those professors go back to their institutions after they've taught those online courses to 100,000 people, and they rethink everything they've done. They question every assumption they've made about what a lecture is, whether they have to do one, why choose any of those particular pedagogies. So I think we're going to see in the next 10 or 15 years really a transformation amongst professors like myself in how we think about what happens in our classrooms and how we use that time and that space and all of that student attention to really profoundly change how people think about and use computing in their work and daily lives.
Well, that's a great place to close off. Andy, thanks for coming on to Software Engineering Daily. This has been a super interesting conversation. I appreciate your blog posts, appreciate your work. Thanks. Appreciate it.
Yeah, I really enjoyed it. Thanks a lot for having me on.